All right, so this is our Python level 3 class. We finished functions last week. So today we're going to a new topic that is class. So let me share my screen. Class. So when you learn how to program in nowadays, you always need to come to learn what is a class, because the class is very important in object-oriented programming, no matter if it is a Python or it is a .NET or it is Java. They all have the same concept, class. So why we need a class? Because object-oriented programming treat everything in the world as an object. Okay, as an object. So everything is an object, and the class is a blueprint for an object. So let's say a human, we create a human as a class. So we may say that you have your hair color, your height, your weight, right? Those are the attributes or properties of the human. So you create an instance of a human. Let's say I create a Smith, and he's a human being, but he's an instance of the class. He's an object. Then we need to know his name, his gender, his height, his weight. So every object has its own copy of the data. So what we have learned, such as class, list, string, are examples of objects. Okay, are example of objects. An object can contain data in the form of fields, often known as attributes, and the code in the form of procedures, often known as methods or functions or behavior. Okay, so the code actually we should say like a method, a function. So a class has two types of members. So one is the properties, one is the behavior. Behavior is the function. So while objects are an encapsulation of variables and functions into a single entity, the objects get their variables and the functions from classes. Okay, so understand this one. So objects are in encapsulation. So let's say Smith, he's a human being, and he has his weight, his height, his age, his gender, right? So all those information are encapsulated in this object, Smith, right? But how Smith get those information, like variables and functions? Functions, let's say, walk, walk, or speak, right? So how can Smith get those? He get it from the human being, because a human being has all those things defined in the class. Okay, so that's why we say a class is the blueprint, a blueprint for an object. So human being is the class. It is a blueprint for the object or in class instance, Smith, right? So classes are essentially a template to create your objects. So they can be thought of as blueprints for creating objects. So we will get into an example to help us understand it. But before we go to the example, let's still lecturing a couple of slides. So we say Python is an object-oriented programming language. It does adopt the object and the class concept. So actually the class is a fundamental building block. It is the underpinning for not only many popular programs and the libraries, but the Python standard libraries as well. So Python standard libraries is also consisting of a lot of classes, like a list I just mentioned, like a string I just mentioned, right? And the tuple, okay? They are all examples of classes. So understanding what classes are, when to use them, and how they can be useful is very, very important. So let's just do one more slide. So if you remember how we define a function, you will know what def does. Def define a function. So if you wanted to define a class, you just use the keyword class. Okay? So let me show you an example. So this is an example. I have a class called my class. You can give it a different name. Okay? And for my class, it has two things here. One is this attribute called I, the variable I. Variable I has the value 1, 2, 3, 4, 5. Right? Another one is the function f. You say use def to define it. Function f, what does it do? It only does one thing, return hello world. All right, so let me give you this one, give you this code, and let's use it. All right, so let me show you how I use it. So let me go to my code flow. This one. All right. So you see, I have a class. The class is called my class. That's the class name. This class has one variable I, one function if. All right, so you have a class. Then let's see something very, very magic. Okay, so let's move on to the next slide. Python class is defined using the keyword class I just mentioned. The class can have properties. In this example, I is a property. And also methods in this example, if is a method. To reference a class, you have to instantiate an instance of that class. You have to instantiate an instance. So what does it mean, instantiate? We just need to create an instance, okay? Or we say we create an object of it. So how do we do that? Let me give you the code in the next slide. So you see here is the code. You see I use test me, that's a variable, okay? I use test me and I set it equal to my class. My class is the class I just defined, right? So now I create an instance of the class. Or we say we instantiate an instance of my class. I did that. Okay, after I do this, then I will call its function. You remember the class has a function called if. So what if does? If return a string. So I just print out that string. All right, so let me give you this line of code, those two lines of code. And then I want you guys to try it. So first, I want you to look at my screen. All right. So here on my screen, let me put these two lines of code here. All right. So you see here, this line of code instantiate the instance of my class. You see how to do that using the class name and then the parentheses here. Parentheses. The parentheses has nothing here. Okay. In the future, okay, later on today, I will show you that you will provide a value in here as well. So right now we do not provide a value. So let's just try it. So now I have an instance of my class. Now I'm using it because my class has a function called f. So I'm using f here. So let me save my code and then let me run it. You see what I got? I print out a hello world. So this is the line of code I printed out. Hello world. Why do I get a hello world? Because I called this function, and this function returns hello world. So that's why if I say test me.f, I got a hello world because that function returns hello world. So I printed that out. So that's what I got. This is what I got. All right, I want you both to try it, see if you guys get the same result. Can you give me your feedback? If you get the same thing, let me know. Okay, how about you, Kate? Very good. So both of you get the same thing. So I hope you understand how to use the class. And you see, you create a class, my class here. Now you instantiate an instance. And you see this instance now has all the things you defined in the class. So now I really want you guys to watch my screen, okay? So let me delete those. Here you see, I use the variable test me. And I know test me is an instance of class, my class. If I put a dot here, you see I got a pop-up window. And you see I got a lot of things here, right? So let's do not care about all the things below I. Okay, I will come back to explain it. But I care about this one. If and I. You see, if and I are what we have defined in the class, my class, and it's available to its instance. Test me. You instantiated it. So now you can got it. So this thing you say you defend in the class, actually you encapsulated all those code, the variables, the functions in this class. And when you create an instance of this class, you instantiated it, and then now you get a copy of all those members, the variables, the methods of the class. So that's why we see a class is an blueprint. Once you instantiated it, and you get an instance of the class, so you get a copy of all those members. So now let me just do this. I put a dot here, and I put an I here, and I use parentheses. All right, so let me save it. You see what I got? I got a 1, 2, 3, 4, 5. And Kate, can you tell me why I got a 1, 2, 3, 4, 5 here? Why? Kate, can you tell me why I got a 1, 2, 3, 4, 5? Okay, then Jerry, can you tell me? Jerry, why do I get a 1, 2, 3, 4, 5? Exactly, you're right. Because I use to test me I, right? And I is defined here in the class. I has a value 1, 2, 3, 4, 5. So that's why when I use test me dot I got this value. It is defined in this class. Does this make sense to your kid? Does it make sense to you? So you are not sure, right? Or you want me to talk about it more? Yeah, I know kind of not. So I wanted to get the not part so I can help you. So can you speak up? Let me know so I can help you. Okay. So you see, you understand that what is test me, right? Test me is just an instance of my class. Because it's an instance of it. So it has everything that this class has. So that is why it has an I. It also has an F. And what is I? In the my class, I is a variable. It has a value 1, 2, 3, 4, 5. So that is why when I use test me dot I got a 1, 2, 3, 4, 5. So that's why you got 1, 2, 3, 4, 5 here. Because this I is defined here in the class. And the test me is an instance of this class. So that is why. All right, let's move on. And you see this in the self parameter in the reference to the current instance of the class. So what does it mean? You see in my code, you have a function called f. In the parameter list, you see you have the self here. All right. Why do I have it? Self is a required parameter in all the functions in a class. So that's why you define a class here called f, and you have to have this parameter. Okay. So what does it mean? So Kate, can you help me read this paragraph?
The self parameter is a reference to the current instance of the class. It is used to access variables that belongs to the class.
Thank you. So what does it mean? All right. You do not see a refer variable here for this function. So it really does not make much sense. But self is referred to the instance itself. So here, if I use F, right? And I did not provide a value because I only have one parameter, self. So self here now means it's the test me copy, the test me instance, the instance of test me. So I will have more example to show you what self is used, but just remember self is required in all the functions in the class. And it means the instance itself. And it has to be the first parameter of any function in the class. You can use it to refer to the attributes of this instance. That is why a method in the class has this extra parameter, which when you use the method, you do not need to provide a value for it. So can you guys look at my screen now? I will not return hello world. Let me just return self. All right. So now I want you to see what I got. I save my code and I print out test me.f, this function. So see what I got. I got a 1, 2, 3, 4, 5. Why I got a 1, 2, 3, 4, 5? Because this function now returns the variable I. And the variable I has value 1, 2, 3, 4, 5. This is how self is used. If you do not use self, okay, you just use return I, and you see the system does not like it. So it flag my code here. It says it has a problem because you did not define what I is. So the system does not know what I is. Okay. So you have to use self for I. That means this I. Okay. Does it make sense to you both? Okay. All right. That's good. So let's move on. You do not have to name it self. You don't have to. You can give it a different name, but it must be the first parameter in any method. Usually develops yourself because it is a convention. So let me give you an example. And someone wants to be unique. He thinks he's smart, so he can do it this way. You see, this is a class called person, and it is a function called my function, and it does not use self, it uses APC. So you see what you got. Hello, my name is APC.name. So what does APC.name means? Actually, it will be this name. Okay, it will be this name. You see this one, he does not use a self, he uses my city object. You see my city object name, and its value equal to the name you passing in. Its age will equal to this age. And I have not started to talk about this one yet. And I will come back to this one later on. But let me give you all this code and I want you guys to try it. Let me give you the code. Okay, so let me just put the code here. Oh, the format is not right. Okay, you see I have this called person. So I then use P1 equal to person John 36. And I will use a person my function. My function, you see what I got. I say, hello, my name is John. But you see, it does not use self here. It uses ABC. Hey, it does not use self. It uses my city object. But you just remember, it must be the first parameter, and it represents the instance you created. This instance, self is a better name. So that's why, by convention, people use self here. All right, so let's move on. I will talk about more. So you see in this example, I have a function called init. That's here. I want you to be aware of this one. It is 2 underscores, and then init, and then 2 underscores, and then the parentheses. And you have 2 parameters. Usually we do not consider this parameter, okay? Because this one you do not have to provide a value. So these are 2 parameters. So what does this mean? What does this mean? Okay, so can you look at my screen? So all classes have a function called this one. It's called init. So what does it mean? This is a constructor of a class. It is a constructor. So what does constructor mean? The constructor, this function is always executed when the class is being instantiated. So what does it mean here? You see my code here. P1 equal to person. When you call person, this function actually is called. And then you come to ask me, hey, Professor Yang, why I do not have that function here? And then why you can call it this way? Okay, so that's the explanation. So can Jerry, can you help me read this paragraph?
If you do not have such a function in your class definition, the system will use the parent's constructor. The parent class of all in Python is object, which has this function.
All right, so why? So let me show you. So I want you to watch carefully, okay? Watch carefully. You see I have test me here, right? And my class does not have that function. So let me show you what does test me do. Can you put a dot here? You see here you have the init, and you have a lot of other things here. And I never ever defined those in my class here. In my class, I never ever had those defined. I only defined I only defined if. But why do I have this? Why do I have the init here? So this is a big topic, a very big topic. In the Python, all classes are the child of object. Object is a class. So it's like this, object. Object is the class of all other classes. It's a parent of all other classes. And if anything is defined in the parent, the children will automatically inherit all those members defined in the parent. So you see, even though I did not define all those functions, properties in my class, but I got those from object because object has defined them. Object has defined them. Okay, so I automatically inherited that. So here you say, even I do not have the init function, I don't have that. It automatically uses the parents init function. And if I have the init function, you see, then when I instantiate my instance of this class, I will have to provide two values because this init function in the class has two parameters. It has two parameters. If you do not provide the value, you do not provide it, okay? If I save my code, the system will not like it. Okay, so now let me run it. You see, I get a problem, right? So it says that init missing two required positional arguments, name and age. So when I instantiate an instance of this class person, I will have to provide two values because the init has two parameters here. If you do not, you will have a problem. And then now let me show you, okay? Let me show you. P1, if you put a dot here, you see the init, it has the name and the age in it, right? So now if I come to the test me, put a dot here, you see the init only has the self parameter in it. It does not have other parameters. So that is why you can directly use in my class parenthesis, and it's an empty parenthesis because its constructor does not have any parameters in it. It does not have any parameters. So that's why you can just instantiate it that way. But once you have parameters in it, you have to provide a value. All right, let me post here. Does all this make sense to both of you? Can you give me feedback? Is it too hard? Or you can follow along? Good, Jerry. Okay, good, good. Very good, both of you. All right, so let's move on. So why do we need the init function? Why do we need the constructor? This is very useful if you need to assign values to object properties or other operations that are necessary to do when the object is being created. So you can do something here. So for us, you see, we assign two values to it. Of course, you do not have to have parameters here, but you can do other things in this function. So this is a place for you to instantiate an instance. Let's say if you create a core class, in it, you can do a block of code. And in the code, you will just say, how much does it cost? Okay, so you can have all those functions, all those code in it. Or you could say, self-wash, wash my car, right? Whatever, I just make that up. And it means in this function, you can do a lot of things when you instantiate an instance of it. So once it is defined with other parameters, you will have to provide values when you instantiate an instance. I already explained that. So you see, I have another class called a student. You also have the name, age, okay? So this time you just use self.name, self.age, right? And here you see print info, self name, age is self age. All right, so let me give you this code and I want you to run it, and then we will come to another bigger topic, very important topic. Let me give you the code. Okay, so let me replace all the code I have here. So you see, I define a class called student. In the student, I have two functions. This is a constructor, and this is one function print out the student information. So you see here, I created two instances, one called st1, okay, and one is st2. When I instantiate the st2, I do not provide a value, so I got a problem. So you will see it's the same problem like this one, but let me save code and run it, and you will see the problem. Okay, you see I got John 36. John age is 36, but when I do students 2, I got this problem. Okay, problem. So this is a very, very important. So now let me do something different. Okay, let me use a different name, a different age. I will say Amy 20. Right? Amy 20. All right. So now let me print out the student's tree information. Okay, so change this to students 2. This students 2. And this also students 2. All right. So let me save the code and let me give you this code. Okay. There's 4 lines of code. Let me give it to you as well. All right. So you see, I got John 36, Amy 20. So I have a question here. We just talked about class is a blueprint, and the instance will get a copy of the data or the copy of the members. The why, when I use the instance st1, I get a John 36. When I use st2, I get a Amy 20. They both are instances of the class, but why are the value different of the instances? Both are the instances of the same class, student. right? So why they are different? So can you answer this question? I give you 1 minute to think about that, why they're different, and then you tell me your answer. Okay, Jerry, you have a good answer. So Katie, do you have an idea why they are different? Okay, so let me explain it. So the difference is that you see ST2, the name is Amy. ST1, the name is John. They both are instance of class student. Why there's a different? All right, so this actually is a very big topic. So let me explain to you. So an instance of a class, it has a copy of the members of the class, but it has its own copy. So it's independent. So students one is one instance. Students two is another instances. Students one is independent of students two. It is independent of students two. So that's why students one has its own name. Students two has its own name. Because when you instantiate it, you give it a name called Amy. Do it here. When you do students one, you give it a name called John. So those variables stores their own copy of the value. All right. So let me do a more interesting thing. Okay. Let me just add. Let me do a student. Wait. Let me just make this equal to 100 pounds. Okay. All right. So now let me do not print out this information. Let me just do here. Oh, let me just pick that one. Let me just do another print here. Print ST1's student weight. Okay. Now let me do this one. ST2's student weight. Let me save it. Then now let me run it. You see, John is 100 pounds. Amy was 100 pounds. So now why they are the same? Why they are the same? Why the student weight is the same? Think about that. See if you can answer this question. That's a very good answer, Kate. All right, because you see, I make a student wait in class member, a variable of the class. In the instantiate, okay, when I instantiate an instance, I did not change its value. So that's why it still has this value, 100. Okay. And then for Amy, it's 100. For John, it's also 100. But now let me do one more thing. Okay. Let me see, st1 dot student weight, and then make it like 120. Okay, let me now see if I run it, you see what I got. You see John 36 and its weight is 120. Amy 20 and its weight now is 100 pounds. Why is that different now? Why is it different? Exactly, Kat. You are so good. You are very smart. Yes, you see here, I change the students one student weight and make it to 120. And this is a big thing. What do I mean, a bigger thing? So once you got an instance, you do whatever on this instance, you see you do not impact the other instance. You say students 2 still has the weight 100, though you change students 1's weight. So students 2 has its own copy and it's independent. Anything you do, you change in student 1 instance, it will not affect students 2. So this is very, very important. You get a copy of the members of the class. If you make a change to any member of the class in this sentence or this instance, it will not change the members of another instance. So it has its own copy. Everyone get an independent copy of the members. So you see John's weight changes, Amy's weight remain. Does this make sense? Can you give me your feedback? How about you, Jerry? Jerry, I lost you. All right, very good. Okay, I think you guys understand very complicated things. That's very good. All right, so let's move on. You can delete the properties on objects by using the keyword del. So you can delete the edge property from the st1 object. You can delete it. So let me just try it. If I do this one, let me copy my code. And that's it. Deal. All right. So now you say I want to print out as students once the student wet. You see what happens. What happens? Yes, it pointed to 100 again because you deleted this instance. Okay, you deleted, so that's why it is gone. It is gone. Okay, so that value does not exist anymore. So that goes back to its original. So let me delete it students 2 as well. Let me do it here. Let me delete the edge. Okay, let me delete the students once edge. You'll see what happens. Okay. So now the edge is gone. It's not there anymore. It is not there anymore. But why I still have student weight? Because the student weight belongs to the class. Here is an instance level. It's an instance level. You say you use this function to instantiate it. So you delete it, so it's gone. Here the student weight, it comes with the class itself. So when you delete it, you just delete what you have in your instance, but the original one is still kept there. You'll see the difference. You see the difference. Let me try this again. Let me delete students. ST2 student weight. All right, so let me just comment out this one. So you see both will return to 100. Oh, it does not exist anymore. It does not exist anymore. Okay. So you remove it. Then it does not exist. Well, I think I have 2 quizzes, 3 quizzes. Let me just quickly do one. Can you give me the answer to this one? Can you guys give me an answer to this quiz? Yes, the right answer is A. Okay, so let me go to the next one then. No, it's actually class. It's a C because you use the class keyword to define the class. All right, so let me quickly just show you the things we learned in the past. All right. So if you understand it now, it's a class. Let me just get this one to show you. So you see ST1, you put a dot here, you have a lot of things here, right? A lot of things. So whatever I have not defined, if you see them, it comes from its parent. And the parent object is the parent of all classes. So now let me just do a different thing. Let me do my string. It's a variable, okay? Let me set it to a string. I like Python. All right. So see, this is a variable, right? It's a string. So let me put this variable here, my string, and I want you to put a dot here. Do you see a lot of things here is available? So many members for a string. Okay. So that means here my string is a class. A string is a class. A class has so many methods and so many properties. And what we have learned in the level 1, let's say the length of it, right? So you can say up, to lower, to using join. So say using find, using index, as using count. Why can you use it? Because actually there are methods in this class. It is defined by the developer when the developer creates a string. So it already creates all those methods there, so you can use. So you can use, right? So you can say use upper Z field, and we spend like probably more than 10 minutes or 15 minutes to talk about what is Z field in our class, right? What is split? Why do you have those? Because there are methods defined in the string class. So if you have a list, let me do a list. Okay. Then now you say, let me put this here, dot. You say you have the append, clear, remove, copy. You have all other methods here, right? You have all other methods because there are also the methods defined in the list class. So list is also a class, right? List is also a class. So now you understand that when we talk about object-oriented classes, programming, everything is a class. Everything is an object. So we used it before, but we did not talk about that. When you get to this level, I hope you understand it and why we use class, why class is so helpful. So let me post here. And do you guys have any question? Do you follow along? Jerry, follow along. How about you, Kate? Very good. So that's all I have. We learned a lot. Actually, class is so important. So we spend the entire week on class. So hopefully you understand the Python programming, why we call it object-oriented. So we learn the class, we learn the class's constructor, that's the init function, and we learned the self parameter, and we learned the the instance copy of the data. So you have your own copy, and you can pass the value to the constructor, so you get your own copy of your data. So we learned all those, and we learned and all the classes are the child of object. though you do not define those methods, those members, but they are available from object. So that's why you see they are available to you, even if you do not define those. Okay, so let me just stop recording and